Welcome to our review on everyday forces. So the first example of an everyday force that we're going to look at is skydiving. Now, when we consider a skydiver, the first thing that happens as they jump out of the plane is that the force that's exerted on them by the earth is greater than the force that the air is exerting on them as they fall. So as a result, they're accelerating. And you can see that being represented by the free body diagram A and also the part A on the graph. So we can see that velocity is increasing, they're accelerating. As they continue to fall and accelerate, then the force of the air on them will increase, and that's represented by part B on our diagrams. Eventually, what we find is that the force of the air acting on the person is equal to the force of the earth acting on the person. So those two forces are in equilibrium, and that's part C on both the graph and our free body diagram. And this is known as terminal velocity. So they won't accelerate anymore because the forces are balanced, so they continue to fall at that constant speed. Obviously, if they continue to fall at that constant speed until they hit the ground, then it would be a rather messy scenario requiring basically a shovel to pick them up. So to avoid the shovel incident, what we have is a parachute which will open. When the parachute opens, then the force of the air will increase, and as a result of that, velocity is decreased, and that's represented on there by part D. So we can see that on that arrow the air is much greater than the weight, therefore we're going to have a reduction in velocity. Eventually though, what happens is those two forces will balance out once more and we reach a new lower terminal velocity, which means you can actually land on the ground still in one piece rather than a weird puddly mess. It's worth remembering when we're talking about terminal velocity that it's not just objects that are moving vertically that can reach this. Objects that move horizontally will also reach terminal velocity when those two forces are balanced or at equilibrium. The last scenario we're going to look at is to explain how rockets are actually able to take off and get up into space. So the resultant force in our rockets has to produce a very large acceleration. And the way that it does that is in the rocket itself we've got a huge amount of fuel, and as that fuel burns it pushes gases out of the bottom of the rocket. So the gas pushes on the rocket and the rocket pushes on the gas. There's a good example of Newton's third law. And when the force of the gas on the rocket is greater than the force of the earth on the rocket, it's going to accelerate and lift off from the ground. Hopefully at the end of this video you can apply Newton's laws. So that's Newton's first law, his second law and his third law. And you can also explain the scenarios that we see in terms of terminal velocity and how things like rockets are able to take off.